Hello and welcome. In this lesson, we're going to take the time to understand our problem at a little bit more of a deeper level so we can get a really good understanding of what's going on under the hood here. And when we introduce the idea of Docker volumes and set it up, it's really going to help you understand exactly what Docker volumes are and how and why they are so useful to us. If we take a look at a quick diagram here, we have our local environment, which again is our host computer that we're working on. And we've set up our project here, this Node Docker Mongo project. And this project has two items in its root folder. And the first one is our Express API, which is a folder that contains all our files and folders for our Node application. And the second item was a Docker Compose file, which we just created and stored there for now. Before Docker was ever involved in our configuration, we would run our server just through the terminal by just using the normal the standard node command, which we set up in our npm scripts. When we ran npm start dev, which we linked up with nodemon, we had our server listening on port 3000 and nodemon was then listening for changes. So nodemon was this npm package that we installed in our project. And this is a tool that listens for any changes within our source folder. And if nodemon detects any changes, so if we write some code in Visual Studio Code and we click save, it's going to detect that there were changes. And then what it's going to do is just, it kind of refreshes our development environment and it reruns this npm run start dev command. And then it kicks off our server again, and then this time it's going to reflect any changes that we made into our code base. And this all happens instantly and makes our development experience really smooth and efficient. I'm sure you know how this all works, so just bear with me here as we build up to the point that I'm trying to make. However, as we progressed with building our application, we introduced Docker into the mix. And so we've added this Docker file that contains a series of commands that Docker will use then to package our code base into a Docker image. So when we run this docker build-t command, Docker then packages up our whole code base. It creates an image for us. And this image contains a base Alpine Linux image. So it's just like a really lightweight distribution of Linux that we can use with Node pre-installed on it. And in addition to that, it contains all our files and folders and all dependency and configurations needed to run our code base within a Docker container. So whenever we run that Docker build command, you can just think in your mind that Docker creates a snapshot of our code base at a specific point in time, and whatever is in the code there will then be contained in that image. So it's like kind of once that snapshot's been taken, that's what you're going to get with running in your Docker container. Once we have those images created by Docker and they tagged with like the latest dev tag or whatever you tend to name it, the next step was then to execute the Docker run command. And what this would do would create a Docker container that's running in on our local machine. And within the Docker container, it contains all those files and folders that we have that's like comparable to our local code base, because that's like a snapshot of it. And so those files and folders are now housed within the Docker container. And within the Docker container, as soon as that run command is executed, the Docker container is going to start our application with that npm run start dev command. And the exact same way as this happens locally, we have nodemon listening for any changes, and the server is running on port 1000. However, the key point here is that nodemon inside the container is only ever going to detect changes for any of the files and folders that are housed within that container. So nodemon within the container is never going to be able to pick up any changes that we make on our local code base, because this instance of nodemon that's running is only listening to the files and folders that are within the Docker container. So essentially, when we execute this Docker build command and we tag and build an image and tag it with the latest dev, it's kind of creating like I've said, it creates a snapshot. And so when we run that container, the container is based off whatever is in that image. The problem that we're having, and this is like a visual representation of that. So when the Docker container is run, we have our npm run start dev that started listening on port 3000. nodemon is kicked up and spun up in the background where it's listening for any of the file changes. But the problem is in our local code base, when we make any changes and rerun the build command, you can see that a brand new image is like a new snapshot of your code base is created. And so the latest dev image is now this new one, like a second one in terms of the timeline. But the Docker container that's running is still based off the image that is now the older version. And so we can continue introducing changes into our code base. Every image that's created is like a new one in the timeline. So we kind of have like a fork in the road where this Docker container contains all the files and folders from two versions or an older version of the image, and the new image that contains the changes that you've made in your code base, a new container will have to be created off that. And so even though we have NodeMon running and the application is running, it's running in an isolated environment. It's got no way at this point in time to detect any changes that are happening in your local code base. I think that's a good explanation of what's going on under the hood. I think we're very clear on what exactly is the problem. And let's introduce the solution now. The way we're going to solve this is by using Docker Volume. And the short version of this is Docker Volumes allows us to persist data beyond a container's lifecycle. So we've seen that the problem is that we kind of have two instances of our code base now, and one can vary over time as we make changes, and that's like on the code base on our host machine. If we make any changes there, those changes are not being ported into the image that has been created. So volumes create a persistent storage mechanism between your host computer and the Docker container. If we think of a Docker volume as a dynamic link that we create between a folder that gets stored on our host computer and whichever working directory that we've declared in our Docker file, Docker will then have a reference to a place on your host machine where it can store and save any data that gets accumulated while the container is running. And by creating this dynamic link and making use of it, we ensure that whatever data is created during the running of the container and the application within it will be saved to your host computer. And so when that container is stopped and then rerun, Docker will be able to re-access any of the data that was saved previously in the previous running of that container. If we do one more walkthrough of a diagram here, if we had changes here which were reflected in red, we built a Docker image and we've run that container. When that container runs, it's going to execute that npm run start dev command, and our server is running on port 3000. And Node will be running in the background, detecting any changes to the files that are stored within that Docker container. But the key thing now with a Docker volume is that it's going to allow us to create this bridge. And so these files that are listed here in our working directory will actually be a reference that is pointing back to our working directory of our local code base. So any changes that we make in our local code base there, which will be reflected in the orange, is going to then move that data across that bridge that we've created, and it's going to update the files and the folders within the Docker container. And so NodeMon will restart your server for you and reflect the new changes because the files and folders have actually changed within the Docker container. I think that takes care of the why and the what, why we're choosing to use volumes, what volumes are. But let's start turning our attention to how we actually set this up. And it's a pretty straightforward process. Once you understand the concept of volumes, a very useful tool that you can use within Docker. To set it up is super simple. All we need to do is add a -v flag to our Docker command. And so you can just remember that, like the V is for volume. And the flag's going to take in an argument where it uses the syntax of you reference a path on your host computer, which we'll call our source of where you want the data to be persisted. And then the destination will be the location within your Docker container where you want the destination of your volume. The Docker run command will then just take this additional -v option into it. And once that's set up, that's kind of all there is to it. And we'll see this in action in a moment. So let's take a short break here. In the next lesson, we'll move back to Visual Studio Code and we'll get hands-on and set this up so we have a volume created and fix our hot reloading. So I'll see you on over there. Cheers for now.